All right, this is Honors Algebra 2 Pre-Calc. We're doing section 3.6 in Algebra 2, which is parametric equations, and this is the second video in the series. So I actually decided to tag on an E3 and P3 that were related to eliminating the parameter because I wanted to show you what happens if one of your functions is more difficult than a linear equation. So in E2 and P2, both equations were linear. I could have picked either to solve, so I easily picked X. What I want you to notice here in E3 is that this one is linear, right? It has a t. And this one is quadratic, right? So quadratic. And it has multiple t's. So and, if that wasn't bad enough, it has multiple t's. So this is going to be the ugly one I don't want to solve for, and I'm going to want to solve x of t. It's not because it's x, it's because x was the friendlier of the two. So I have x equals 3t, which means I'm going to use an x over 3 for t in the y equation. So in this equation, right, in the y equation, anywhere I see a t, I'm going to replace it with an x over 3. So my answer is going to be y equals x over 3 quantity squared minus a 4 times an x over 3 plus a 1. I would absolutely take this as a right answer. This is a right answer. Right? All you were asked to do was eliminate the parameter. Congratulations, you did. Now, if you want to clean it up and distribute the squared, you could get that this is an x squared over 9 minus that 4/3 x plus 1, or you could write that as a 1/9 x squared minus a 4/3 x plus 1, or any combination of that sort of thing. That's also okay, but remember, you risk making a mistake, right? So these are also okay. So let's go ahead and do a P3 that's the same idea. So pause me if you want to do it by yourself. So here, I'm going to point out that it's the y that's the easy equation, right? The y is the easy one. So I'm going to say y equals t plus 2, which means I'm going to replace the t's with a y minus 2. When I do that in this uglier equation, right, I'm going to get that x is y minus 2 quantity squared minus a 5 times a y minus 2 plus a 3. This is absolutely a right answer, and this is where I suggest you stop. But if you really want to do more math, you can, right? You should stop right there. If you wanted to do more math, you would actually have to FOIL out y minus 2 times y minus 2. So you'd get that x is y squared minus 4y plus 4. You distribute this negative 5, so you get negative 5y plus 10 plus 3. So your final answer would be x equals y squared minus 9y plus 17. And that's not wrong, but you took a big risk by doing a lot more math than you had to, right? So again, I would totally stop right here. You did the job, right? The job was get rid of t, you got rid of t, right? Cool. So let's go ahead and move on past this eliminate the parameter stuff. So far we've covered 2 of the 3 skills that I said you need, right? Number 1 was know how to graph these things by hand and on a calculator. Number 2 was know how to eliminate the parameter. Before we do number 3, I want to show you a kind of cool side effect that is on one of the pages in your book, but just to show you how it works. So here's a cool trick. Recall that when we did 2.5 and we learned about inverses, we knew that the way you find an inverse is by switching the x and y. Well, that means that if you have a parametric function, right, or a parametric set of equations, you can find the inverse by just switching the x and y, literally switching which one's x and which one's y. The other cool thing about parametric is that you don't just have to graph functions, right? Parametric, remember, we've seen things that fail the vertical line test. They're not functions, right? So this thing right here, which is this graph right here, this is clearly not a function, right? Because it fails the vertical line test, right? So this is not a function, right? Because it would fail the vertical line test. You see how it hits here twice or any number of places. But what you'll see is that you're able to graph both functions and non-functions on a calculator in parametric mode, which is cool because in a calculator, in function mode, right? If you go back to mode, in function mode, you can only graph functions. That makes sense because it's called function mode, right? So it's pretty cool. So again, what you'll see here, and I'll erase what I wrote on top of that so you can see it better, is that you're able to graph both this thing, this is x equals t and y equals t squared, which is this graph right here, right? And this thing, which is x equals t squared and y equals t, and those are inverses. So it's cool that if you want to graph inverses in parametric, you just switch which function is the x. So see how here the x was t and the y was t squared? Well, you just switch those 2 functions and now you have the inverse, which is pretty cool. So that's just an interesting side effect. So let's go on and talk about word problems. So your book teaches you to solve word problems with parametric equations poorly. really, really poorly, and it's infuriating and frustrates me every time I see it, even though I've been teaching this book for a very long time. Here's the problem. So if we talk about the method that's listed in example 3, basically what they do, and you can look on page 198 of your textbook to see this, but basically what they do is they teach you a way to like use your eyeballs to yield a rough approximation. If you have a graphing calculator, why would you want a rough approximation? You should know how to do it to get the right answer. So we're going to spend a little bit of time to talk about how to do it properly, despite what your book says in example 3 on page 198, because it's frustrating. And their example 3 is going to be our example 4 because I added that extra example with quadratics. So here's the issue. Functions that your calculator lets you do, like functions not as in math functions, but functions as in an operation on the calculator, that your calculator allows you to do in function mode. So if you look at function mode, I'm going to go back to function for a sec. If you go to second calc in function mode, you can second calc 0 or value or min or max or intersect. Like you can do, in fact, you can do other stuff that you don't know what this is yet. You don't know what dy dx and what this integral symbol is yet, but we're going to get to it. So in your calculator, you're able to do second calc 0 and find when a curve intersects the x-axis. Well, if you're doing a word problem, when the curve intersects the x-axis is totally when the thing hits the ground, because the x-axis is y equals 0. That's hitting the ground. So in word problems, we're frequently asked, when does something hit the ground? Well, that's second calc 0. Sometimes we're asked, if you throw a ball in the air, what is the maximum height? Well, that's second calc maximum. The problem is that those skills, those things that we want, are only in function mode. If you're graphing something in parametric mode, so let's go to parametric mode now, I'm going to hit that same second calc in parametric mode. Well, that list is very different. In parametric mode, you cannot second calc 0 and you cannot second calc max. And that's going to matter for word problems, because if you picture, most of the time when we do these word problems, when you're in like a physics class or something else, right, this is what your word problem is going to look like. It's going to look like somebody threw a ball went in the air, hit a maximum height, came back down, hit the ground. Well, this is the max, and this is called the 0 or the root or the x-intercept, right? So if you want to find when you hit the ground or what the maximum height is, well, those are going to be skills that you can't do in parametric mode. And your book just kind of weirdly walks past this without talking about it and has you estimate things, and I think that's annoying, so we're not going to do that. So let's walk through how to do this the correct way. Unfortunately, the reality of the situation is that to do this the correct way, the best option you have is to eliminate the parameter, put the graph in your calculator in function mode, and use this second calc 0 and this second calc max that we're going to want, and then reverse engineer the time from that. It's not awesome. I'm going to own that this is going to be, to do this properly is a little more difficult. But realistically, it's not sensible for me to teach you some slapdash, crappy way of doing this, because that's just a waste of our time. So we're going to walk through how to do this properly, even though your textbook doesn't address it. So in example 3 in the textbook, and again, we're going to do this the right way, even though this is going to be a little bit more complicated. So we're going to ignore, so this is on page 198, right? And they do it not incorrectly, but they do it in a way that is not yielding you a good answer, okay? So an outfielder throws a baseball to a catcher that is 120 feet away to prevent the runner from scoring. The ball is released 6 feet above the ground with a horizontal speed of 70 feet per second, which is why that x of t is 7 dt, and a vertical speed of 25 feet per second. The reason that this is quadratic is because of gravity. When you get in calculus, you're going to learn how to actually figure out all of these physics formulae from scratch, and it's awesome, and calculus makes physics way easier, so we will get there eventually. The catcher holds the mitt 2 feet off the ground. So the following parametric equation describes the path of the ball, okay? The questions we're asked are, when does the ball reach its greatest altitude? And can the catcher catch the ball? Okay, so here's the issue. I know that this graph looks something like this. The ball starts 6 feet off the ground. It's going to get thrown. It's going to travel in a parabola, right? And we actually want when it hits 2, not when it... So we know that 120 feet away, there's a guy, right? 120 feet away, there's a guy, and he's trying to catch the ball, right? So we're 6 feet up. He's trying to catch the ball 2 feet up. That's what's going to happen. Okay, so basically, let's walk through what both of these is asking, okay? So if A is asking us to find the max y value, right? But that's a function we can't do in parametric, right? So this is a function that if we want to do it accurately, we need to be in function mode in our calculator. Well, function mode means that we need y's and x's. So in order to do A, we need to eliminate the parameter. Well, thankfully, we learned how to eliminate the parameter with quadratics when we did E3 and P3. So I have x equals 70t. So x over 70 is my t, which means what I'm going to put in for my y, and I can put it in my calculator exactly like this. Sorry, they put the 6 first, is 6 plus 25, and I'm going to put this x over 70, right, minus a 16, and I'm going to put x over 70 and square it. This is exactly how I'm going to type this in my calculator. So I'm going to go back to mode, because remember I was showing you that parametric doesn't pan out the way we want. I'm going to go to function, and in my y equals, I'm going to put in exactly what I typed here. 6 plus 25 in parentheses, I'm going to have x divided by 70, right, minus a 16, and then in parentheses, I'm going to put an x divided by 70 quantity squared. There's no reason to clean this up because my calculator is going to do all of the heavy lifting, right? So what I want is I want to find the maximum y. But notice that they said when, right? So that when is going to mean, so what they're going to want me to do after I find this is they're going to want me to find t, which is annoying. So in the final answer, they're going to find that they want me to find the t when there's that max height. They don't actually want the max height. They want find the time of the max height. So in order to find that, right, in order to find that time of the max height, I'm going to go ahead and hit graph. Now, this window is not going to suffice, and here's the reason. If you picture this, I know that I'm going out 120 feet, right? And I don't know how high the ball's going, but I know that if my window is 10 by 10 by 10 by 10, like a standard window, I'm not going to be seeing what I want to see. So I tend to keep my x's negative and my y's negative so that I can see the axes, because I like that. So I'm going to go ahead and make my x max into 100 and let's do 130 feet, because I know that I want to see up to 120, right? And I don't know how high the ball's going to go, right? I don't know how high a person has to throw this to make it go this far, but I'm just going to guess that 30 feet is probably safe. If I'm wrong, we'll change our window in a sec. So I'm going to graph, and hey, there it is. So here's the guy throwing the ball. He throws the ball, it hits a max height, and then eventually it would hit the ground if the catcher doesn't catch it, but we'll talk about the catcher catching it in a sec. So in order to find a max in function mode, I can do second calc, and I'm going to pick max, which is 4. So when you want to find a max, I know the max is somewhere up here. I want the highest y value. So here's the idea. I want to go to the left of that highest y value. So I look and say, okay, so far 7.64 is the highest I saw. I go to the left of that a couple, I hit enter. Now it says go to the right, and it even has an arrow pointing me to the right. So I'm going to cross that highest value I saw, hit enter, and then it says guess, which just means go back to the middle. That's what the arrows are telling you to do, and take your best guess. So here's my maximum. So I'm actually going to take a quick shot of this, if it'll let me. All right, I'm not sure if it'll let me screenshot while I'm doing a recording or not. We're going to find out. Hey, it did. All right, cool. So I'm going to take a shot of this and put it here so we have it. Okay, so let's look at this for a sec. Now, right now, this x, I can find t using this x. So currently, at this exact moment, after I second calc max, this x in my calculator, this 54 point blah, 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 if I quit out, do second quit, and you hit the letter x, you'll find that it is exactly that stored number. Well, I know that t is x over 70. So I now know two things. I know the x coordinate at the max and the y. If I want the t, all I would need to do is do that x, not a rounded version of that x, but the actual x divided by 70. And I find out that the max time, because see how it says t is x over 70? The max height, rather, happens 0.781, give or take, seconds into when this, so I'm going to go ahead and screenshot that guy too and drag him over here. Okay, so my max height happens, sorry, take that back. My max height happens at the moment when the time is that 0.781, right? So that answers my first question. The first question is, when did the max height happen? And my answer to A is when t is approximately 0.781 seconds. And I'm going to suggest that you always round or truncate to 3 places. Truncate means that you cut off like this, which would be 0.781. Round would mean that you take into account the 2 to decide if you have to round the 1, which would also be 0.781. So in this case, either answer is the same, okay? So that's my approximate time when the max happens, when the ball hits the outs. Now let's look at what the second question's asking, because again, I did point out this is not easy. I get that. Nobody's saying that this is easy. All right, so the question is, will the catcher catch the ball? Now we're assuming that the catcher can't move his arm, which I realize is not necessarily, like somebody could move their arm. So really what this is asking is, what is the y when x is 120 feet, right? Well, here's my argument. I can find that. So because we're saying 120 feet out, we want to know how high up is the ball, right? Because there's a guy's hand, like the glove. There's a guy standing here. He's got a glove out. Is the ball too high, too low, whatever, right? So does he catch the ball? Well, here's my argument. We already have this formula where we had y is 6 plus 25 times x over 70 minus 16 times x over 70 quantity squared. I don't need time. There's no part of part B that asks about the time, right? There's no part that does it all. Part B just asks about when the ball is 120 feet away, which is where the catcher is, he's 120 feet away, what's the height of the ball? So the easiest way to do this is also to use my calculator. So if I go to my calculator, I have a couple options. One option is to go to the graph, and if I hit trace, I can type in x is 120, and it'll jump to where x is 120. So when I hit trace, right, I hit trace, and we jump into where x is 120. And sure enough, what we find is that when x is 120, the y is pretty close to 2 feet, right? So when x is 120, my y is 1.836 or 7, depending on if you round or truncate feet, which is close to 2 feet, right? So this is approximate. So that's close enough to 2 feet that I would say that this guy is going to move his glove and catch the ball. So he's holding his glove 2 feet high, that's really close to 2 feet. We're assuming he can move his glove a couple inches. Now, if the y value had turned out to be 10 feet, I'm not assuming the guy can jump into the air, like levitate and catch a ball that's 10 feet up. But this is a close enough throw that it is a safe assumption he's going to catch it. What I want to show you about this, though, is that in both of these cases, the only way to find the correct answer, the actual answer, is to change your function, or to change your parametrics into function mode and use your calculator in that way. So again, my answer to A was this time. My answer to B was yes, but I should explain why, right? So when I answer B, I need to say, oh, hey, here's why. I found this y value. Yes, it's close enough. Okay, so we're going to do one last problem, and that'll be the end of our 3.6. So for our P4, same basic idea, right? So a batter hits a ball 3 feet above the ground. Horizontal speed is given to us. We know it's vertical speed. We know all sorts of this other stuff. It doesn't really matter because they gave you the equations. So we're told that there is a fence 250 feet away and 10 feet high, and then they ask us a couple questions. How long will it take the ball to reach the fence, and will the ball go over the fence? Okay, so there's a couple ways that you can deal with this. In this one, you actually can get away with not changing things. So this, right, so this first question is asking you x of some time equals 250. They want you to find the x, or I'm sorry, find the time, right? So I know that that's 98t equals 250. So the time should be 250 divided by 98. So that one I can actually find. I'd still use a calculator to find the number, but I can find that one without changing modes. So if I did 250 divided by 98, I get a time. Now I'm going to hit stow, and I'm going to store this as alpha A. What this does is it makes this A in my calculator anytime I want to use it. The reason that's advantageous is because that way I don't have to deal with when I have to plug in that t, which I'm going to have to do at some point. So 2.551 seconds is when it's going to hit the fence, right? So that's my answer to A. And I'm going to make a note that I stored that in my calculator as A, because you don't want to use a rounded answer to answer other questions. You want to use the exact answer. And so storing that means I can use that A. Now the question is, will the ball go over the fence? Well, what that's asking is, what is y at that 2.551, right? Because if it's greater than 10, it's going to go over the fence. If it's 10 or fewer, it's going to hit the fence. So in order to find that, I need to plug in, I'm going to plug in 3 plus 45a minus 16a squared, because I've stored this as a in my calculator. So in my calculator, I'm going to do 3 plus 45 alpha a minus 16 alpha a squared, because again, I stored that number in my calculator as a, and I'm going to get that it's 13, so this is going to be 13.672 or 3, depending on how you round or truncate, right? Just a reminder, the way that works is truncate means cut off, which would be just cutting off after the 2. Rounding would mean that the 6 rounds the 2 up to a 3, okay? You don't have to put both answers, you just put one, right? So that's my y value at that point. So the answer is yes. Since 13.672 is greater than 10, it clears the fence, right? It clears the fence by about 3 feet. So in that case, we were actually able to use just really just basic math to figure it out. We didn't have to graph it in a calculator. Now, you still could have figured that stuff out, but the big hints that you need to change stuff to function mode are usually when you're talking about things like max or min, or talking about something hitting the ground. Those are things that, so hints that you want to, hints that you're looking at something where you want to be in function mode, right, are when you hear max or min, or when you hear hits the ground, because that means 0, right? So hits the ground is going to be a 0. So again, not everything that your book teaches is exactly how I would teach it, and when that happens, I just tell you what I would tell you anyway, which is kind of my job. So cool, that is 3.6, and that's the end of our chapter 3 in Algebra 2.